All right, so today we're diving into something called Holochain. And it's built on a pretty wild question. What if our digital world behaved less like a rigid machine and more like a living, breathing thing? Yeah, let's get into it.
I mean, really think about it for a second. The way our internet works right now is mostly based on these big, centralized servers. And yeah, it's powerful, but it's also just so clunky, so fragile. You hear about data breaches, server outages, single points of failure. It all feels so brittle, almost unnatural. Why is that?
Well, for the longest time, we've basically been stuck with two main models. First, you've got the old way, the one giant brain. All the information sits in one spot, which is basically a giant, glowing, please hack me sign. And if that one brain goes down, poof, the whole app is dead. Then along came blockchain, the global hive mind. Cool idea, right? But its solution was to make everybody hold a copy of everything and agree on every single change. It's like calling a global meeting of 8 billion people just to decide if you can post a picture of your lunch. It's secure, sure, but man, is it inefficient.
So the folks behind Holochain decided to look somewhere else entirely for inspiration. Not to bigger computers or fancier code, but to the most successful, most resilient information system we know of, life itself. You know, a design pattern that's been working out the kinks for about 3.8 billion years. No big deal.
Now, to really wrap your head around this, you kind of have to do a mental backflip. In the world of Holochain, you aren't just a user logging into somebody else's system. You are the system. You are the cell.
This idea is called Agent-Centric computing. So instead of being a guest in, say, Facebook's digital mansion, you're a sovereign participant. You're running your own copy of the application on your own device. The power, the data, it all starts with you. And just like every cell in your body has its own DNA, every agent in Holochain has a source chain. Think of it like your own personal, private diary. Every single thing you do, write a message, make a payment, it gets recorded right there, in order. Then it's sealed with your unique digital signature, which makes it totally tamper-evident. It's your history, and you own it.
Okay, so we're all individual sovereign cells, each with our own DNA. That's pretty cool. But a single cell isn't an organism, right? For that to happen, you need connection. So let's see how this all builds into something much, much bigger.
Exactly. A cell floating around by itself is just a cell. Life happens in the interaction, in that shared space where cells can talk to each other, share things, and work together. A digital organism needs that exact same thing.
And this is where the distributed hash table, or DHT, comes in. Now, don't let the technical name throw you. Just think of it as the organism's connective tissue. It's the fluid that flows between all the cells. It's the public space where information is shared. But here's the absolute genius part. Nobody holds the whole thing. Every person just holds a small, random piece of it. It makes the whole system incredibly lightweight and fast for everyone.
So what does this connective tissue actually do? Well, for starters, it keeps data available even if the person who created it goes offline. It lets different cells find each other and gossip about new stuff that's happened. It's super resilient. If part of the network gets damaged, it can literally heal itself. And maybe most importantly, it gives the whole organism a way to know when something's gone wrong.
And that brings us to what is honestly the most brilliant part of this whole biological metaphor. Because if you're going to have a digital organism, it needs a way to fight off sickness. It needs an immune system.
This quote just nails it. This isn't just a computer network, it's a social organism. It has a shared memory, and, critically, it has a way to defend itself.
So that's the million-dollar question, isn't it? How does a totally distributed network with no boss and no central server fight off an infection? How does it spot a digital virus or a rogue cell trying to poison the well?
The secret is in something called validation rules. You can think of these as the rules of the game, or even the laws of physics for that specific application. They're baked right into the app's DNA. And here's the kicker. Every single cell, every agent has a full copy of these rules. This shared agreement on what is healthy data and what isn't, that's the immune system.
To check out how this plays out, say another agent sends you some data. If it follows the rules, your cell goes, yep, this looks good, and integrates it. The organism is healthy and happy. But if someone sends you a digital pathogen, data that breaks the rules, your cell doesn't just block it. It issues something called a warrant, which is basically a digital antibody. It's solid proof of the bad data, and it warns all the other cells nearby. The organism identifies the threat and isolates it. Just like that.
Now, life inside this organism isn't just about shouting things into that public DHT space. The cells have much smarter, more direct ways of talking to each other.
So agents can make direct, private calls to each other, totally end-to-end encrypted. They can also delegate tasks. One agent can give another permission to do something on their behalf, which is super useful. And they can even form binding agreements by countersigning something together. It's like a secure digital handshake.
So let's zoom out. When you put all of these pieces together, the sovereign cell, the connective tissue of the DHT, and this amazing collective immune system, what kind of digital world do you actually end up with?
You get what you might call the biological advantage. First, power and data ownership go back to the individual, you. Second, it's massively scalable and efficient. Get this, unlike a server that crashes when too many people use it, this organism actually gets stronger and more resilient the more people join. And finally, just like life, it can survive damage, it can heal, and it can adapt.
And that brings us all the way back to the beginning. For so long, we've built our online worlds like these rigid, fragile glass houses. Holochain is suggesting we could be building them more like resilient, adaptable, living coral reefs. So it leaves you with this one final, really fascinating thought to chew on. What kind of digital world could we build if it finally started acting a lot more like a natural one?